Picture your body running a quiet maintenance shift every single night. The moment you stop putting food in, a microscopic crew of workers powers up inside every cell. They identify damaged proteins, dismantle worn-out machinery, and haul broken pieces away for recycling. Scientists have a name for this overnight operation. They call it autophagy. It is, quite literally, your built-in defense against getting older from the inside out. And a growing body of evidence shows that intermittent fasting is one of the most reliable ways to keep this crew working overtime. But here is what most people miss. The vast majority of intermittent fasters are accidentally shutting their own maintenance crew down. They follow the rules on paper, they skip a meal, they tighten their eating window, they feel disciplined. Yet underneath the surface, they are making subtle errors that do not just cancel the benefits of fasting. In some cases, these errors push their biological clocks forward. In 2025, a landmark human trial published in the Journal of Physiology became one of the first to show, directly in people rather than in mice, that time-restricted eating can elevate autophagic flux, the actual rate at which cells clear out damaged components. This is a major finding because for years the strongest autophagy evidence sat in animal data. But the same research underscored an uncomfortable truth. The way you fast matters far more than the fact that you fast at all. Here are 5 mistakes that quietly turn intermittent fasting from an anti-aging tool into something that may be aging you faster. The first mistake is how you break the fast. Autophagy does not flip on and off like a light switch. It builds intensity the longer you go without food. The deeper into the fasted state you travel, the more thorough the cellular housekeeping becomes. But the second your body senses incoming nutrients, insulin floods your bloodstream, the mTOR pathway switches on, and the cleanup grinds to a stop. Now imagine doing all that hard work for 16 hours and then breaking the fast with sugary cereal, a fruit smoothie, white toast, or a glass of orange juice. You just doused the cleaning crew with metabolic gasoline. It is the equivalent of letting a team scrub a room spotless and then backing a dump truck up to the door and emptying it. The work does not just halt, the progress gets buried. Studies on post-fast meal composition show that the first food you eat dictates how your body exits the fasted state. A steep insulin spike does not simply switch autophagy off. It slams mTOR into overdrive, swinging the body from repair mode into aggressive growth and storage mode. A bit of mTOR signaling is healthy. Whiplashing between cellular cleanup and metabolic stress with refined carbohydrates may actually drive aging rather than prevent it. The fix is to lead with protein, fat, and fiber. Eggs and sautéed greens, a small handful of nuts before lunch, salmon over avocado, or a bowl of plain Greek yogurt with seeds. These foods generate a modest, slow-rising insulin curve that lets your body step out of autophagy without trashing the work it just did. The grim irony is that millions of people fast for 16 hours and then erase the entire molecular benefit in the first 15 minutes of eating. The second mistake is fasting long, but eating late. This one rarely gets discussed, and it might be the most damaging error on the list. Your body operates on a roughly 24-hour rhythm. Insulin sensitivity, glucose tolerance, cortisol release, melatonin production, every metabolic gear in your body has a preferred time of day. And that preference is not subtle. Your engine runs cleanest in the morning and early afternoon, and it begins powering down as the sun sets. A systematic review published in the journal Nutrients dug into how different eating windows affect cortisol and melatonin, 2 of the most important circadian hormones. The results were eye-opening. Protocols that skipped dinner pushed evening cortisol down and lifted morning cortisol slightly, the exact profile of a well-tuned stress axis. Protocols that skipped breakfast, which is what most modern fasters do, blunted the natural morning cortisol surge, a pattern linked to a disrupted HPA axis and poorer metabolic markers. Separate research in the journal Cell Reports showed that meal timing rewires peripheral circadian clocks inside organs like the liver, deciding when the genes responsible for repair and metabolism turn on. Eating at night drags those local clocks out of sync with the master clock in your brain. This mismatch, known as circadian misalignment, has been linked to faster biological aging, chronic inflammation, broken glucose control, and a higher risk of disease. A randomized crossover study found that eating just 1 or 2 hours before bed, while melatonin is already rising, sharply reduced insulin sensitivity and glucose tolerance compared to identical meals eaten earlier in the day. Think of your circadian clock as a conductor running an orchestra of organs. Late-night meals force the liver to play its solo in the wrong movement. The result is not a symphony. It is metabolic noise. If your current schedule pushes your eating window from noon to 8 at night, you may be leaving real anti-aging benefits on the table. Shifting earlier, even to something like 8 in the morning until 4 in the afternoon, consistently outperforms late windows in studies measuring metabolic health, circadian gene expression, and autophagy markers. The third mistake is letting your muscles slip away. Here is a hard truth that few fasting influencers will say out loud. If your fasting protocol is causing you to lose lean muscle, you are not slowing aging. You are accelerating it. Sarcopenia, the steady decline of muscle mass and strength with age, is one of the most accurate predictors of premature death, frailty, and physical decline in older adults. Muscle is far more than how you look in a mirror. It is the largest metabolic organ in your body. It is the primary place glucose gets stored after meals. It supports your skeleton, protects your joints, and decides whether you stay independent in your 80s or end up in a chair. A review published in Frontiers in Nutrition raised an important flag. Muscle protein is in constant flux. Old strands break down, new ones replace them, and the trigger for new construction is highly sensitive to how often and how much protein arrives. Muscle protein synthesis peaks at around 0.4 of a gram of protein per kilogram of body weight per meal. Squeeze all your eating into 2 meals inside a 6-hour window, and you generate 2 muscle-building signals per day. Spread the same calories across 4 meals over 12 hours, and you generate 4. Over months and years, that gap compounds, especially in older adults whose tissues respond more slowly to protein in the first place, a phenomenon researchers call anabolic resistance. A 2024 randomized controlled trial offered some reassurance, showing that 10 days of intermittent fasting with matched protein intake did not impair muscle protein synthesis. But the authors made a point of saying that older adults with sarcopenia need far more study, and that the long-term effects of permanently shrunken eating windows on muscle preservation remain unknown. The solution is not to stop fasting. It is to defend your muscle while you fast. Aim for 1.2 to 1.6 grams of protein per kilogram of body weight daily. Spread thoughtfully across your eating window, with at least 25 to 30 grams per meal. Pair fasting with resistance training, the single strongest signal you can send your body to hold on to lean tissue. Fasting without lifting is like sweeping a beautiful house while letting the foundation crack. Eventually, the whole structure gives way. The fourth mistake is fasting too aggressively. It comes from a tempting but dangerous assumption. If a little fasting is good, more must be better. A study tracking healthy young men through 30 straight days of 17 to 19-hour daily fasts followed autophagy genes, inflammation markers, and cellular aging markers across the month. Autophagy gene activity climbed early on, exactly the expected response. But by the end of the 30 days, several autophagy markers had drifted back toward baseline, while inflammation markers showed a complicated, time-dependent pattern that did not fit the simple narrative of more fasting equals more benefit. A broader review in the journal Advances in Nutrition went further, warning that prolonged severe calorie restriction with an overdriven autophagy response can tip cells into something called type 2 autophagic cell death. The cleaning crew stops tidying and starts dismantling the building. Picture controlled burns in forestry. Small, deliberate fires clear out dead brush and let new growth thrive. Let the fire run too hot or too long, and it does not just consume the dead wood. It takes the healthy trees with it. A 2025 study using MRI imaging during a 12-day extended fast found that while muscle function held up, muscle volume dropped by roughly 5.5%. The researchers believed most of that was glycogen and water loss rather than true muscle breakdown. But the finding still raises questions about what aggressive fasting does over months and years rather than days. The takeaway is that moderate, consistent protocols, somewhere in the 14 to 18-hour daily range, appear safer and more sustainable than chronic extreme fasting. The goal is to spark autophagy on a regular schedule. not to hold the throttle to the floor. The fifth mistake is what you drink while fasting. This one sounds trivial, but it can quietly unravel everything. Most people assume that anything without calories is safe in the fasted state. Diet sodas, sugar-free creamers, branched-chain amino acid supplements, electrolyte powders with sweeteners, flavored sparkling water. None of them seem like food, but autophagy is not governed only by calories. It is governed by nutrient-sensing pathways like mTOR, AMPK, and insulin signaling. Several zero-calorie compounds can switch those pathways on without delivering any actual energy. Branched-chain amino acids, for example, are powerful mTOR activators. Sipping them during a fast effectively tells your body that protein has arrived, which shuts down autophagy whether you ate or not. Certain artificial sweeteners can trigger what is called a cephalic insulin response, where the taste of sweetness on the tongue alone prompts the pancreas to release a small dose of insulin in anticipation of sugar. Whether this is enough to fully break a fast is still debated, but it is far from harmless. Imagine arming a security system and then nudging the front door open every hour. Each nudge resets the alarm, and the cleaning crew pauses, wondering if they need to clear out for an incoming delivery. The safest options during a fast are plain water, black coffee, and unsweetened tea. These have been studied in the fasting context, and either preserve or actively support autophagy. Coffee in particular has been shown in animal studies to trigger autophagy through pathways that are independent of caffeine. Step back and look at all 5 mistakes together, and a single pattern emerges. Every one of them comes from treating intermittent fasting as a stopwatch. Just do not eat for 16 hours and the magic happens. But your body is not a stopwatch, it is a living chemistry lab. What you eat to break the fast matters. Where your window sits in the day matters. Whether you protect your muscle matters. How hard and how often you push the fast matters. And what passes your lips during the fast matters too. The science is encouraging. Time-restricted eating genuinely appears to raise autophagic flux in humans, touching one of the deepest hallmarks of biological aging. But that benefit is delicate. It is easily wiped out by poor execution. The people who will age the most slowly are not the ones with the longest fasts. They are the ones with the smartest fasts. If this video shifted how you think about fasting, hit the like button, subscribe, and pass it along to someone who needs to hear it. Your future self will thank you for it.